All right, you crazy kids. Here's your worksheet for today. This is predicting products. We're going to be walking through these. I'm going to voice over kind of how I go through this, and hopefully this will help you out. So let's pick this one right here first to start out. For our synthesis reaction, I can tell it's a synthesis reaction because I have two elements that are going to be combining together. Not much else going to reoccur here. And it looks like we have a metal and a non-metal. So my metal, its charge is going to be Ba2+. My non-metal is O2 negative. So my product is going to be BaO. It's an ionic compound. I know that is going to be solid at room temperature. We also have to balance this. So we'll put a 2 here and 2 here. And that's nice and balanced. Get that 2 out of the way there. For decomposition, let's pick the one in the middle again. That worked out well the first time. So here we have a metallic chlorate. Metallic chlorates break down into metallic chlorides and oxygen gas. So my metallic chloride is going to be made up of magnesium and chlorine. So my product here is going to be MgCl2. This is going to be solid room temperature. Ionic compounds are solid room temperature. And I'm going to be having some oxygen gas as well. Oxygen is gaseous room temperature. You should probably know that by now. If we look over here, it looks like I have 2 chlorines, so that's good, but I have 6 oxygens here. So if I put a 3 here, I have 1 magnesium, 2 chlorines, and 6 oxygen. That's 1 magnesium, 2 chlorines, and 6 oxygens. I think we're balanced out, and that looks kind of nice. Clean this up a little bit. All right, single replacement reactions. So single replacement reactions, what you're going to be doing is replacing the individual element with a similar element in the compound. Now let's take a look at maybe the middle one again. So this calcium is going to be replacing the aluminum. All right, so similar things switch places. I need to take a look at my activity series to see if this is actually possible. So we're taking a look at the two, aluminum and calcium. So aluminum is here, calcium is here. Because calcium is higher on the chart, it means it's more reactive. All right, so a more active metal can replace a less active metal. So if I look at my example, calcium has the ability to come and replace aluminum in the solution because it is higher on the activity series. So I need my calcium acetate. Calcium is going to be a +2 charge, and acetate, C2H3O2, is a -1 charge. So my product here is going to be CaC2H3O2, 2. This is a single replacement reaction. That means my compounds must be in solutions. So I'm going to put a little AQ here. And I'll have elemental aluminum on the other side. Aluminum is solid at room temperature, hence the little s. We do have to go ahead and balance this here. Looks like I have 3 acetates here. I have 2 acetates on this side. So that's not going to really work out. But if I put a 3 here and a 2 here, now I have 6 on both sides. Yeah, that messes up my calciums. I got to put a 3 there, and my aluminums, put a 2 there. But after that, it all works out. Double replacement reactions. We're having such luck going in the middle here. We'll go in the middle one more time. So in this case, my magnesium and my calcium are basically going to switch places. All right. This is kind of easy because magnesium and calcium both have a predicted charge of +2. So my compounds aren't going to switch up that much. I'm going to have calcium carbonate and magnesium chloride. Even though these are ionic compounds, I can't list the states of matter here as both solid because maybe they're not. Remember, this is happening in solution. So I'm putting 2 solutions together and I'm going to see if a precipitate forms. That's the whole idea of a double replacement reaction. And actually a better name for a double replacement reaction is called a precipitate reaction. So now what I need to do is look at my activity series. I'm going to look up calcium and carbonate, and I'm also going to look up magnesium, let's use pink here, magnesium and chlorine. So let's start with magnesium and chlorine. So here's magnesium, and here's chlorine or chloride. And they match right there. It's a little AQ. So that's going to be this state of matter. You can put a little AQ here. AQ. Fantastic. Now let's look up the calcium and the carbonate on the other side here. So we look at our solubility table. Here's calcium. And here's carbonate. Right there, when they mix, I see a little S. That means this reaction does, in fact, occur because you have a precipitate forming. And when it's a precipitate forming, we use a little downward arrow. That lets everybody know that a precipitate has formed and this reaction does take place. If that was not a little s, if they were both AQ, you would then cross this off and write no reaction. But that's not the case in this case. not the case in this case. We did have a precipitate react, so everything worked out. We do have to go ahead and balance, but believe it or not, we're already balanced, so that reaction is done. Combustion reaction, I only gave you 2 here. Believe it or not, there's a third one that I'm going to show you in a second, but let's take a look at just what happens here. How do I know this is a combustion reaction? Well, I have oxygen as a reactant. And we also have a hydrocarbon, or a mix of carbons and hydrogens. When you have a hydrocarbon and oxygen reacting, you always get the same products. You get H2O. Well, I usually eat CO2 first. I don't know why it's forced to have it. CO2 and H2O. You can write those either way. It's fine. Which one comes first does not matter to me. But I know that these are going to be both gaseous at room temperature. And you're going to say, well, Estes, why is water gaseous in this case? Well, water is gaseous in this case because I'm burning methane gas. All right, there should be a little triangle here to indicate that heat's going to actually be required to kind of spark this reaction, and then you would have gaseous water being formed. In fact, whenever you burn any hydrocarbon, you form water. It's just water vapor, one of those cool things. We do have to balance. Let's go ahead and take a look. I have 4 hydrogens on one side. I only have 2 on the other side, so I need to put a 2 here. And now we have 4 oxygen on one side, 2 on the other side. I need to put a 2 here. And that looks balanced. I did say that there's another hidden combustion reaction somewhere in this whole chart, and it is right here. If we notice, we have oxygen as a reactant. So this number 2 in the synthesis reaction would also be a combustion reaction. And if that was on a test or a quiz and I was having you identify the actual type, you would have to list both synthesis and combustion to get full credit there. All right, so I walked through a few of these. Why don't you guys try the rest of them, and we will figure it out together. See you out there.